Hey guys, and welcome. Today we're going to talk about projectile motion. Basically, we're going to take an object that's in flight and find the maximum height that this object can reach. First, let's recall the graph of a quadratic. If you remember, this is vertex form of a quadratic. To find the vertex, we take the opposite of the number that's inside the parentheses with the x. So this would be a positive 3 for your x value. And the y value is the number that's being added to the end. So in this case, it's a positive 4. So to find my vertex, I go right 3, up 4. That is the point 3, 4. And then to find the rest of my points, I look at the number in front. My normal pattern is left 1, up 1, left 2, up 4, right 1, up 1, and right 2, up 4. Your pattern changes because of that negative 2 in front. The negative changes all of the ups to downs, and the 2 multiplies the constant. So instead of up 1, I'm going down, and 1 times 2 is 2. Instead of up 4, the negative causes the up to become a down, and multiplying 4 by 2, I get 8. Again, instead of up 1, the negative causes the up to become a down, and 1 times 2 is 2. Instead of up 4, I go down 4 times 2, which is 8. So once we find our vertex, we simply follow this pattern. Left 1, down 2. Going back to the vertex, I now go left 2 and down 8. On the right, I go back to the vertex and go right 1, down 2, and right 2, down 8. Because of the parabolic shape of the graph, and parabolic simply means this U shape that it takes, we use this graph to model the flight path of an object that has been thrown, launched, projected, etc. So you can kind of picture the object going up to its maximum height and then falling back down to the earth. When you throw an object, it will follow the path of an arc, so its path is modeled by a quadratic or a parabola. For example, a ball is thrown into the air, and its height h in meters at any time t in seconds is given by the following equation. Find the height of the ball in 2 seconds. So we're trying to find h, and we are given the time. The time here is 2 seconds, or 2. So all I'm going to do is leave h as a variable, but plug in 2 everywhere I see a t. So I have negative 5 times 2 squared, plus 40 times 2, plus 45. This becomes negative 5 times 4, plus 40 times 2, plus 45. Negative 5 times 4 is negative 20, plus 80, plus 45. And then working from left to right, negative 20 plus 80 is 60, plus 45 is 105. So what we just found is that the height of the ball after 2 seconds is 105 meters. Now the next question is, how long does it take for the ball to land on the ground? So how long? That's asking us, what is the time? How long does it take for the ball to land on the ground? Landing on the ground is telling us something about height. When it's on the ground, the height is 0. So what I'm going to do is put a 0 in for h and solve for t. That will tell me how long it's going to take for the ball to reach a height of 0, or to be on the ground. Now, since I have a variable squared, I'm going to need to factor the quadratic in order to solve it. So first, to factor, I'm going to take out the GCF. Here I can take out a negative 5 from all the factors. So negative 5 leaves me with t squared minus 8t minus 9. I then use my diamond on this trinomial inside parentheses. On the top of my diamond, I'm multiplying to a negative 9. On bottom, I'm adding to a negative 8. My two numbers are negative 9 and positive 1. So I split up my negative 8t with negative 9t plus 1t. So I still have that t squared in front, and I still have that minus 9 behind, and everything else stays the same. I now split this in the middle and take out the GCF on the left, which is t, leaving me with t minus 9. And on the right, I can only take out a positive 1, leaving me with t minus 9. To factor completely, I take out the t minus 9, and I'm left with t plus 1. I still have that 0 equals and negative 5 on the front. Now to solve, I set each of these factors equal to 0. So each factor that contains a t, I set equal to 0, giving me t minus 9 equals 0 and t plus 1 equals 0. I end up with t equals 9 when I solve the first and t equals negative 1 when I solve the second. So we have two options. How long does it take for the ball to land on the ground? Well, it could either be 9 seconds or it could be negative 1 second. Having a negative time doesn't make any sense, so it's going to take us 9 seconds for the ball to land on the ground. As we move on to the next slide, I'd like for you to think about this. The highest point that this object reaches is the maximum. To find this highest point, we need to find the vertex of the parabola. So if you remember, a parabola looks something like this, and the vertex is the peak, or the very highest point. So to figure out what is the greatest possible height that this object can take, we need to find the vertex of the parabola. The maximum is the y value of the vertex. So what we're looking at is what is the distance from the vertex to the ground. So what is that y value of the vertex? We don't really care how far left or right it went, we just care how far up the object went, and that is going to be your y value. A ball is thrown into the air and its height h in meters at any time is given by the following equation. This is the same example that we were using on the previous slide. So remember, x equals negative b over 2a. This is the x value of the vertex. So in order to find your vertex, you start by using this formula. That gives you the x value. Then you go back and plug it in to find the y value. But here, notice, we're using t instead of x. So to find our vertex, I'm going to start off with t equals negative b over 2 times a. So I have t equals negative 40 over 2 times a, which is negative 5. So that gives me negative 40 over negative 10, which reduces down to a positive 4. So the t value at the vertex is a positive 4. Well, that's the time, but I want the height. So what I'm going to do, now that I've found at what time the ball is at its max height, is plug that back in to figure out what is the maximum height of the ball. So h equals negative 5 times 4 squared plus 40 times 4 plus 45. H equals negative 5 times 16 plus 40 times 4 plus 45. Negative 5 times 16 is going to give us a negative 80 plus 160 plus 45. And working from left to right, negative 80 plus 160 is positive 80 plus 45 is 125. And we're talking meters for our units. So in the first step, we found at what time does it take the maximum height. And then in the second step, we found what is the maximum height by plugging in that time. The vertex is the point 4, 125, and the y value gives you your max height. Go ahead and pause the video and try this next one on your own. You should have, after 2 seconds, the ball reaching a height of 88 meters. How long does it take for the ball to land on the ground? You should have had positive 6 seconds. One of your answers would have been negative, which you should have disregarded since time can't be negative. The ball will reach its maximum height in 2.5 seconds. Plugging that back in to find the actual maximum height of the ball, you should have found 99 meters is the maximum height that the ball will reach. Thanks so much for watching. That's all I've got for you today. I hope you enjoy the rest of your day.